to the internet. This is what it looks like. Wow, amazing. Wow, cool. All right, so I'm just gonna talk to you a little bit about kind of like the history of the internet. We're gonna fly and breeze through that, and then we'll actually get down to the nitty gritty. In terms of like the weekend labs, did you do all of them? Did you click through on the bottom? There's a couple where it talks about there's like a 3-hour video from Avi. Did you watch that? Okay, yeah, you all did very good. Thank you. Yes, now. Cool. I'm just gonna summarize the majority of it so we can kind of be on the same page. So, the history of the internet, Volume 1. It all started 5,000 years ago. They say that it will be born. And there it is. And so the internet is essentially, it's just all wires. Everything in the internet is just wires. I know I revealed that massive bombshell, which nobody was surprised about the other day. It's just what? Links, lists, and images. That's all the internet is. And forms, excuse me. Wow. Now I'm just adding on to it. Wow, it's becoming less mind-blowing. That's all it really is. So this is really what happens. I talked about the request-response cycle. Really what happens in the internet is that you ask for information and then you just get a response. And so I just want to show you something before we get started. This is what is known as Markdown. Right? You can actually see this image. You can see that this is boulderized. And then this right here is a link. So actually, let's take a look at what the text looks like side by side. Bloop. Oh, wow. It's a little bit different. Cool. So I have this little pound sign, right? You guys are old enough to understand the pound sign? I'm older than I look. Okay, very good. This is not the hashtag to me, it's pound sign. And so what happens if I actually add a couple more? And I say, ooh, wow. Nothing crazy spicy, right? It just gets a little smaller. And the idea is that how I write something is going to influence how something is displayed. So far, that's not a difficult connection to make, right? And so that's basically how the internet works. Wow, congratulations. But really what it is this is all just regular plain text. It gets transformed into something that's just a little bit more visually appealing. And so you can kind of see these images. You could see different text styles and colors. All right, that's my time. Thank you very much. That was my TED Talk. Thank you for coming. And so that's really what it is. Except if you take it one step further, what we can do is we can take a look at, oh, that was embarrassing. Have you ever been to this powerful website? Okay, nobody? All right, very good. I'd hope so. Okay, we're in trouble? No, just kidding. The idea is, how many of you have done some of the pre-work, the HTML and CSS labs? It's okay if you didn't really get through all of them, but the idea is this whole website, it's just a bunch of divs. All right, if I wanted to see a form, I'm going to make a form tag. Let's take a look at HTML form. W3 schools, bless up. All right, so if I do try it yourself, just like in Markdown, if I have something like this, that's what it's going to appear like in the browser. So if I were to add something, right, like a button tag, and I'm going to close the button tag, and I'm just going to say yeet. And if I run that, I will now see a new button called yeet. So far, so good. This is just the plain English. This is the code for it, but that's what actually appears on the screen. And that's how the whole internet works. And I keep saying that because this is what happens. I, from my computer, will send a request. Right? I'll go to something like Twitter, Bookface, Instagram, and then I will go to that website, and then it will just send me back HTML. My browser knows what to do. If the computer sends back this, my browser will display this. And that's really all the magic. And so if we take a look back, all right, I don't need this anymore. That was just a crummy example. This is everything that's happening. Right? There's just these giant wires that run underground throughout the entire world. And then it's just wrapped in some petroleum jelly, and some steel wires for protection, but ultimately they're just these optical fiber cables. And what they do is they transmit data at the literal speed of light. That's why the internet is so fast. Do you remember back in the day, has anyone heard of like a LAN party? Like a LAN party? Oh yeah, bunch of gamers over here. GLHF. So the idea is that if I were to connect a computer to another computer, just through a cable, I can send information through that cable from one computer to the next. That's not very complicated. The idea of the whole internet is that every single computer is connected. It just seems kind of crazy. Who here has moved before? You like moved? Okay. What an easy thing to do, right? Disgusting. No, it's terrible. It's a terrible thing to do. But we should all do it. But what is the first thing you do? It's 2020, you gotta move. The first thing you do after you pick the location of the place, you're like, cool, I got the movers. What's the first thing you do? What's the first phone call you make besides to grandma? I'm like, oh, I just got my own place. It's amazing. Wi-Fi. That is the correct answer. It's the first thing we do. And who do we call? Ghostbusters. Right? Yeah. You call, I used to be a Roadrunner, Time Warner Cable, Spectrum, right? Wow, I just dated myself. Yeah, so you call like Spectrum or something, and what are they actually called? What is Spectrum and Spectrum Wireless, Cox Cable, AT&T, Fios, what are they? What is the ISP? They are Internet Service Provider. And that's all they are. And what do? They tell you like, hey, we're gonna be there at approximately 8 to 7 p.m. I'm like, thank you, that's useful. So you take the whole day off, all right? And then they come whenever they want. And then what do they really do? They just come in with a box, right? Just some box, kind of looks like that with some lights on it. And they plug it into the wall, right? Have you seen the coax cable? It looks a little bit like this. That's really what's happening. Your building is wired. Every single unit in your apartment and or house will have a couple of these. They're buried underground and they connect to this large conglomerate of wires. And so what happens when you plug that in and you're like, great, can I get internet now? Just straight from that box. No. Negative, Batman. What do you really need? That's the modem that actually connects you, that will translate the signal, the light, into like internet, will connect you. You need the router. That's what's going to give you the Wi-Fi. So this is what's actually happening. Your modem is connected to this line that's allowing you to connect to like essentially every computer in the world. And then you plug the router into that, and this is a mind-blowing fact. I don't actually understand how this works. But this is what's really happening. It will take that, and then it will translate and beam it through the airwaves. And anyone that is receiving, so you have to connect to your router, right? Anyone that is connected and receiving will then be wirelessly connected through the modem to the router to the rest of the world. That's how it's actually happening. The frequency in which this is beaming, there's Wi-Fi in this room. The information is physically and literally around us in bits, in ones and zeros. You're like, oh my God, look at the data. Right? I look like a psycho. But that's really what's happening. And so when you're connected to the router, you have to make a request through the router, through the modem, through the line, and then where does it go? The cloud? Whatever that means. But let's explain. So, how are we feeling so far? I know I was like talking a lot. Yeah? Yar? Let's do it, Yar? Okay. So, I'm sorry. Normally this is a better performance. And so this is what's really happening. Boop, boop, boop. Boop, boop, boop. Let's go to awesomewebapp.com.
I have a question.
Send it.
So I don't know how long ago this happened. Didn't like Thailand lose all like access to the internet because somebody was messing with like their servers or something like that? What can you like kind of like explain it?
Yeah, I can.
Like did somebody mess with like these giant wires?
And so can you. Yeah. That's a good question. So the question is like, how did Thailand lose all internet? Cool. Let me get through this like terrible explanation, and then we'll see if we can figure it out together. All right, bet. So here's what's happening, right? You, cell phone. Oop, I went to art school before this. So this is what it looks like. This is your cell phone, right? You're like texting and stuff. Texting on an Excel spreadsheet. Thank you. We all recognize and accept that it's a phone. So like through the airwaves, right? This is like an airwave. It hits the router. This is your router. It looks like pretty good, right? There's some extra wires, I guess, here. You know?
Looks like
Wow.
very super clean.
This class is delightful. No, just kidding, right? So like it's going through the wires, it's hitting the router. But when we go to a website, we go to something like bookface.com. This is what's actually happening, right? You make the request and it hits the router. How many of you remember back in ye olden days when you had to memorize everyone's phone number? Do you remember that? You had like one best friend, maybe two if you were lucky, your mom, your home number. You have to remember that. It's crazy. Who here remembers phone numbers now? Wow, very impressive. Probably a worthless skill though, right? Okay. It's dated, right? I mean, I kind of know how to skateboard. Useful? Probably not. So the idea is, actually it's kind of cool, but the thing is, when you want to call somebody now, do you dial that number? Do you go, hold up, let me call my friend Jenny, 867-53099, right? Do you do this? No, what do? You just look up Jenny on your phone and then you're just like, yo, watch this. You just touch it and then all of a sudden Jenny's like, hello, I'm like, new number, who dis, right? So this is really what's happening. If I were to go to something like bookface.com, wow, look at that, amazing. But what's really happening is, I was logged in, I guess. Look at this clown over here. Look at this guy. Hey, all right, that's enough of that. So what's really happening is this. It is doing what is known as like a lookup. Every single website address, right? Just like a cell phone number calls one particular phone. What about your home address, right? Your home address, that's unique to you, right? If I was like, I live at 123 Fake Street, nobody else could really live there unless I'm illegally renting it in a dupe. But anyway, so the idea is that like I live at 123 Fake Street, that's my address. If you want to come see me, that's where I live. That's not really where I live. And the idea is that's linked to you. The same happens on the internet. If I go to facebook.com, there is a specific address that the request needs to go to, right? It beams through the wire, it hits the router, then the router is like, okay, I need to know where to send this request. Where is facebook.com? Where does that live? It will do what is known as a DNS lookup. And so in your router, when you go to facebook.com, you can trace it, and it will give you this IP address. Does anyone want to go to Instagram.com, or would you rather go to like 164.33.21.7? Come check out my profile page. That would be impossible to remember, right? Nobody would look that up. And so this is all kind of stored internally. If I were to take this, boop, 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 and I were to go to a new tab, and I were to actually go to this IP address, it will resolve to Bookface. That's where it lives on the internet somewhere. So when I go on my phone, right, I make the request to Facebook. I want to check my friend's feed. I want to learn more about Corona. It's wild. It will do that, right? It will, what? It could be anything, right? And so it will do that. It will look up the IP address, and then in the IP address, the router, the modem, the ISP provider will be like, oh, you're looking for like 31.13.71.36. It will then know where that server is. That server probably lives somewhere in like Virginia, because real estate's much cheaper there than it is in New York City, right? It'll just go to a server in Virginia, and then when it gets to the server, all you're saying is like, hey, what's there? That's what this request is. It will give you back something that looks like this. It'll give you back all of this HTML. That's what gets sent back through the wire, HTML, just this text. Your browser will get this text and be like, oh, I know what to do with that. I know what to make it look like, and then you will see the Facebook website. That's really the whole internet, every single request. If I try to log in and I put in my email and then I hit sign in, it's going to find the IP address and it's going to send that data. When it gets to the server, it's going to be like, what do you want to do? It's like, hey, here's my username and password. Log me in. Server's going to be like, oh, bet, fam, got you. And then it will send back more HTML. That HTML will probably be my logged in profile page. And then I see the number one thing is like, hey, our mayor had put something out. I'm like, cool, bet. And I click that link, guess what? It's going to resolve. It's going to find the IP address. It's going to go to the server, and the server is going to give me back HTML, and then I'm going to see the page. So it's that request hits the server does something, and then the response. And that's the whole internet. How do we feel about the request and that response cycle? So far, so good? All right, cool beans. So everything is through these wires, which means what is the greatest threat to the internet today? Ripping these wires, right? You know who likes to attack them?
Sharks.
Sharks.
That's false.
It is false, yeah. It's a myth, but it's funny. Yeah, it's not true. Occasionally they will bite them, but that's not really that big of a problem. That's why they have to be so thick. And so we have Batman saving the day, saving the internet over here. Yeah. I don't know if you know this, but like actually in this movie, it's Adam West. He has like shark repellent, and he sprays the shark. Okay, all right. I guess 1970s humor doesn't carry over. R.I.P. R.I.P. Cool. Sorry for your loss. All right. Let's actually figure out, kind of like, let's demystify some of these terms that you've heard. All right. So you've heard of HTTP, right? So what does that stand for? What does HTTP stand for? Amazing. Very good. This class has done its homework. Right. So what does that really mean, though, right? Let's break this down. HT just stands for hypertext. And then TP is just transfer protocol. So let's break this whole thing down. Hypertext, that's the first half. When I talk about HTML and I go, hey, this is all that HTML that it gets sent over, that just stands for hypertext markup language. That means that whatever I write here is going to get marked up so that something else will display. Just like earlier, when I was going through here and I said, bloop, bloop, bloop. Well, actually, I did say that. But this is a Markdown. And then whatever I write here, this is what it will look like. So I have a hypertext, right? So it looks like those script tags, the button tags, the p tags, the div tags. And then I need to send them through the internet somehow, which is literally what transfer is, right? I'm going to transfer this information. And so the last thing is this protocol. What does protocol really mean, just in English?
Rules.
Rules?
An agreed upon process.
Wow. Very good. Thank you, Dr. Miriam and Dr. Webster. Yeah, absolutely, a process, right? So it's a way to do something. So there is a standardized way to send over and transfer hypertext back and forth between computers. That's all that is. How do we feel about HTTP? Does that make a lot more sense now, especially with the request response cycle? So I need to know a standardized way to break down my HTML, translate every single character, right? In my button tag, boop, boop, boop. In my button tag that I just made, these will compile back to ones and zeros in binary. And that's it. Like, this button can be broken down to ones and zeros, and then I send ones and zeros through the internet at the speed of light, and it comes back to your computer. Your computer's like, oh my god, 1000100010, button, got it. And then a button tag will appear. That's not the actual like binary. I just made that up, but cool. Yeah. All right. So, is this not plugged in? Sorry, I'm just gonna make sure my laptop doesn't die. That's embarrassing. Bloop, bloop, bloop. Ooh, wow. Does anyone else get that weird like feeling when your battery's low and you plug it in, you just feel real good? Okay, just me then. All right. So I guess I'm a psycho. All right, so HTTP. There are certain types of HTTP requests. So when I am asking for information, I'm literally going to make what is known as a GET request. I want to get information. So I want to see what's at facebook.com. I want to see what's at chettaylor.com. I want to see what's at yourboy.com. I'm making a GET request for information. If I want to submit any data to the server, like I'm trying to log in, I will have to post data to the server. So if I wanted to go to, all right, it's like, I probably should screen this, but whatever. It's gonna, cool. Look at that load, amazing. Oh wow, #1 trending thing, amazing. Didn't see that coming, cool. So I made a GET request to reddit.com. It resolved to some sort of IP address, hit the router, went through the internet wires, right? Found the server, and gave me back this HTML. And then my browser knew what to do with it. And it displayed this. That was a GET request. If I wanted to log in, so I click login, this modal pops up, very fancy. I have to put in my username and password, and when I hit sign in, that is no longer a request for information. I have to tell the server, here's my credentials. The server will then have to process that and then send back a request. Either something like, yo dog, that account doesn't exist, or wow, you're logged in, here's your profile. It will have to determine dynamically, based on what I sent, what the response should be. And so that is a post request. And then naturally, if I'm building a website, I should be able to send a delete request to delete something, and then a patch request to update something. Those are the 4 real main ones that you'll have to learn, right? Get, post, patch, and delete. Cool? This will become a lot more familiar as we get through the lecture for the rest of the time. Yeah? All right, cool. All right, let's actually build something so it'll make a lot more sense. All right, so there is a package, there's a gem called rack. And what rack will do is it will allow you to spin up a local server on your machine so that you can make a request to yourself and pretend you're a different computer, and then you can send a response to yourself and pretend you're a different computer to simulate the request response cycle of the internet. All right? So here we have an incredibly complicated class called song. Nice. All right, any questions? Bless up to mod 1. All right. Probably inherit from active record, but whatever. All right. All my app does is it requires this rack gem. I'm going to pull in the app file, and then I'm just going to run app.new. So I'm creating a new class of app. I'm just going to create a new instance of it. So here's app. And let me break this down Barney style. So I'm pulling in Pry, my best friend. And then I'm going to pull in that song file that I just made, the very complicated song app. Yeah? This is the class app. And what call is like this built-in method, and it will invoke an instance of app. And it's going to receive something called an environment. This is not really important right now. We can get into this later if you want to. It's going to establish 2 things, the request and the response. These are just objects that exist. Cool? All I'm saying right now is if someone makes a request, right, which is going to be this request object, and it goes to a method called path, and it's going to go to /songs. If someone goes here, /songs, I'm going to go through all my songs. I'm going to create an LI. Remember what map does? It does that one-for-one transformation. I'm going to take a song object and create an LI with each one. And then I'm going to write to the server an H1 that says, yo, here's my bomb song list, followed by an unordered list of all my list items, all my song LIs. So if someone goes to /songs, I'm going to see this. Else, if someone goes to artists, I'm going to see this. Otherwise, I'm going to say, hey, you haven't found it. And then I'm going to finish that response. So if a request comes in, I check to see the route, the path, and then I send back a particular response, and then I finish the response. Cool? So let's do that. I'm going to go to my rack server. I'm just going to go rack up. Powerful. Cool? And I'm just going to go to localhost 9292 because that's what rack is defaulted to. And I will see what? What should I see based on this code here? Yeah, not found. Let's take a look. Bloop. Gasp. Wow. Stud. Cool. Now let's look back at the rack server. If there is a request at a path of /songs, I should see this different thing. So if I go back to my website and I go to something like /songs, if the request goes to /songs, I will send a different response. And that response will be this bomb song list. If you take a look at this very fancy HTML I have here, it looks pretty familiar. So let's add some songs. Does anyone have any songs? Look at these songs over here. Powerful. Any particular songs you guys like? Okay, very good. Very good. Very good. What's hot right now? Okay.
No Time to Die.
No Time to Die. Okay. No Time to Die. Okay. Smiley face. So let's see what happens. I added some code. All right. But remember, my server's running. I don't have the code uploaded to the server yet, so I need to, oh, this is disgusting, shut the server down and then rerun it so now the code is actually saved and now it's running on my server. So if I were to go back to /songs, I have a new song object. Let's see what happens. Bloop. Wow, No Time to Die. Amazing. Cool. Let's go back. If I have a request to /artists instead, what should I see? What should the server respond with? Just a p tag that says artist, right? So if I were to go to, oops, I'm embarrassing, /artists, wow, I just have this one p tag that says artist. That's the whole internet, right? Like I sent a request to a particular route, /artists, it hit something in my server. It knew what to do if that route was good. It formulated some sort of response, and then it sent the response. I made a request, server did something, I sent back the response. That's the whole request response cycle. Only in Mod 2, we're going to get much fancier than this, and we're going to build full-fledged apps. Cool? All right, yeah?
What's that equals tilde symbol online?
Okay, this and path.match exactly, they're similar. This is just syntactical sugar. You won't have to worry about this. This is a rack-specific kind of like syntax. Cool. So we're going to build on top of rack. We're going to use something called Sinatra, which like you should probably have started the labs already. We're going to talk about that in our afternoon lecture. But that's really it. Sinatra will build on top of this so you can handle the routes. If someone goes to /yourboy, it will do something, send a response. If it goes to /ESPN, it'll do something, and then send a response. Cool? The last thing I want to talk about, and then I will let you go, is this a dynamic or is this a static website? And what does that mean?
It doesn't change unless you put something like that. You can't change anything as a user. So
Close.
Like if you like were to type, you made a change on your app.rb and then it doesn't update the thing.
If I make a change to app.rb and it doesn't update my website.
You have to quit out of the Markdown program and restart again.
Close, very close.
The
Like that guess.
information doesn't change unless you make a change to it.
That is true, but that's not exactly what I'm looking for, but it's very true.
It's sort of like there's no user interaction. Like if a user goes to your website, they can't delete, they can't put anything.
Close, very close. Ooh, it's tough, right? Spicy. All right, so the routing has nothing to do with dynamic websites, and so here's the idea. The dynamic website means that I'm going to build the site based on data from the database. So if I update the database, the website should be updated. So think about this. Let's take this one step further. I did song.new, right? If I were to create 10 songs into my database, and this goes through all my songs, if I update the database, it will update my website. If I wanted to hard code everything, it would create a static website, in which case it will look the same unless I go in and specifically change every single thing. Here's what I mean. Instead of this fancy code here, bloop, I'm just going to put in here an li tag that says all night long Lionel Richie, classic. Cool? And then here, what's another good song? It's a classic. Frank Sinatra, the artist, very good. Classic. Modern Love by David. DC David. DB, cool? All right. If I were to do that, it's always going to send back these 3 LIs no matter what. If I change something in my database and I update a song, will my response be any different? No. As a web developer, right? I'm building an e-commerce store. I'm shopping at Uniqlo, whatever, I'm Asian, right? I'm shopping at Uniqlo and I want to update a price on a t-shirt. I'm going to go into the database and update that price. What will happen to my website if I use a static website? I will also have to go in and change the price on the website.
Every place that t-shirt.
Every single place that t-shirt is. It's disgusting. 1-star experience, right? That's a lot of work. So you want to dynamically pull information from the database. So let's take a good example. Let's take a look at an example. Do you think that somebody goes to reddit.com every single day and updates every single thing on there? No, that'd be crazy, right? Like if I were to go to this website and I'd be like, okay, great, here we go. It's 23:58. I'm sorry, 11:58 at night, right? For all the Americans in here. And I'm a developer. I'm like, great, I've got 2 minutes to update this website. Am I going to go edit this H1 tag? Am I going to edit how many comments are in here? Every single time more comments come in, I'm going to go back into the website, go, okay, now there's 5.6 thousand people that like it. That would be crazy. That would be static. So if I were to create something like, boop, boop, boop. If I were to create something like this is my Reddit database, then all I have to do is update the title, change the title, and then Reddit will be updated. And so that's what we're going to learn to build in Mod 2. Cool? We're going to learn to build databases, pulling from that database, and creating these dynamic websites. All right? Based on the request response cycle. Are there any questions? Amazing. All right, that's all I have for you this morning. Thank you.